takes practice. It takes lots and lots of practice. Just to know when you're through. That's the hard thing. To know when you're through. Yeah, like, Lord have mercy. Can I stop now? The chain rule is used to differentiate composite functions. If I just give you y equals x squared plus 1, you could have done that last night. You could have just differentiated that term by term. But if instead of just plain old x squared plus 1, I give you square root of x squared plus 1, that's going to take the chain rule. Sine of x doesn't take the chain rule, but sine of ugly does. 3x plus 2 does not take the chain rule, but ugly to the 5th does. E to the x plus tangent x doesn't take the chain rule, but e to the ugly tangent ugly does. Here's where the word ugly comes into play, and there's no better way to say it. When I see this, I think, oh, that's square root of ugly. When I see that, that's sine of ugly. That's ugly to the 5th. That's e to the ugly tangent ugly. And the chain rule says to differentiate, for example, start with the easy one, ugly to the 5th. To differentiate ugly to the 5th, you not only get 5 ugly to the 4th, but you also have to take the derivative of the ugly.
I have no idea what you just said at all.
I know. You can replay it at home, but you need to see an example. That does not make sense until you see an example. I know. Miss Sarah?
5 is ugly. What is the last non-ugly? To the 3rd
No.
or to the 2nd?
Quit saying
I
that.
didn't understand. The 3x plus 2 is the ugly that's being raised to the 5th power.
Ugly is really
Where?
confusing.
Just
I know. I'm not through yet. Let me just keep talking. Some things I have to talk for a few minutes and work a couple of examples, and then you go, oh, that's what she's talking about. This is one of those times. Let me, don't panic on me. Let me show you the chain rule in writing, and then it makes more sense seeing an example than it does just seeing it written out. If y equals f of x is a differentiable function, if it's something you can take the derivative of, if it's some function of ugly, and ugly is some other function, g, then to take the derivative of y with respect to x, you have to take the derivative of y with respect to ugly and multiply it times the derivative of ugly with respect to x. Ooh, I didn't like that either. I didn't like that at all. Let me try one other thing. Let's try this way, and then you're just going to see an example. All right? This way it says the derivative of a composite function. A composite function can be written f of g of x, correct? All right? The derivative of f of g of x, you take the derivative of f and multiply it by the derivative of g. I don't expect that made sense either. So let's see an example. We're going to work almost every problem, every even problem in this section. That's why we have 2.5 days to do it, because that's how much practice it takes. Page 161. There's no pretty way to write down the chain rule, so I'm not even going to write it down. Let's just start with the easiest, number 1. Number 2 is a little bit harder. 1 is y equals 5x minus 8 to the 4th. All right. What I'm saying is really important here, so don't be talking to each other. When I see that, through my years of experience, I don't even look at that and go, that's 5x minus 8 to the 4th. I go, that is ugly to the fourth. And when I take, let's say I didn't know ugly was anything other than plain old u, what would be the derivative of u to the fourth? 4, same old ugly, cubed. You would just bring the 4 out front, keep the same old ugly, and subtract 1 from the exponent. We're not finished, but here's what we have so far. This is 4 ugly cubed is the derivative of ugly to the fourth. Now, by the chain rule, I also have to have the derivative of the ugly. Well, this is what I call the ugly. What's its derivative? I highly recommend that you practice saying this at home. This is ugly to the fourth. The derivative of ugly to the fourth is 4 ugly cubed times the derivative of the ugly.
Would it be like?
Hold on just a second. You said wouldn't the derivative of the ugly be what?
So how is it 5?
Because that is the ugly. And what's its derivative? What's the derivative of 5x minus 8? Yeah. I didn't actually mean to write that 4. I just meant to say that's ugly, and then ugly is raised to the 4th power. Hold on. Let me say it one more time. The derivative of ugly to the 4th is 4 times same old ugly to the 3rd times the derivative of the ugly, the derivative of the inner function. Now, Miss Ashley, what did you want to say?
Can you say it like f prime of u times u prime?
Absolutely. Yeah, and that's how it's written in the book. Yeah. This is f prime of u. This is the derivative of u to the 4th. This is the derivative of u. Now you can clean that up to be 20 times 5x minus 8 cubed, and that's the derivative. All right, let's do another easy one. Number 2. Y equals 1 over square root of x plus 1. Is there a way that I could write that without a radical and without a quotient? How? Almost. It's not just x plus 1 to the 1/2, it's x plus 1 to the negative 1/2 because that came from the denominator. All right. What is the ugly being raised to an exponent? X plus 1 is my ugly.
Your conference is scheduled to end in 2 minutes.
That's okay. We just got a 1-minute head start on 3.4. That's the ugly. The derivative of y. If you didn't know u was anything special, what would you say is the derivative of ugly to the negative 1/2? Negative 3/2. Negative 1/2, same old ugly, subtract 1 from the exponent, but then I'm also going to have the derivative of the ugly. What is the derivative of the ugly? The derivative of x plus 1 is just 1.
Let's try 3/2. Wouldn't that be positive 3/2?
Negative 1/2 minus 1.
Oh.
So I would write this as 1 over 2, or negative 1 over 2 times x plus 1 to the 3 halves.